Hey folks, welcome again to Advent of Code in F Sharp. We are at day 10. This is my second attempt. I tried day 10 yesterday with limited success because I was going into a weird direction. So this is take 2. And take 1 was something with an unfold function and that was way too complicated. But I had a sleep on it and I'm willing to try again. What have I done? I have parsed the input, so I parse instructions into nope and no ops and addx, and that is it. That's all I have done in the code. And then I did some thinking, or not some thinking, some noodling, and I mapped out the 2 examples from the description. So I got more of a sense of what was happening or what was expected, because the during and the phrasing of the description at the start of the cycle, during the cycle, and at the end of after the cycle, that was very confusing for me personally. But when I just wrote everything down in a stepwise form, I think I might have an idea on how to solve this. The idea is to run every instruction and have every instruction run a list of cycles. So a no-op has takes only 1 cycle, so that generates 1 signal. An add takes 2, so that always generates 2 values, or has values for 2 cycles, and then flatten all those sublists into a single list, and then in the end we have a huge list for all the x values for every cycle. And there's 2 functions I'm hoping we can use, which is the scan function and a collect function. And yeah, let's take a look at those functions. Maybe scan first. Scan has exactly the same inputs as a fold, but the output is different. Instead of having a single state value, scan returns the intermediate results of a fold as well. So every element that the folding function visits, we also get a value out of it. So I think that's a nice match for today's problem, or at least for the way I am looking at it, with the whole generate all the values for all the cycles that an instruction takes. And the second one is, I have not checked this, but I think there's a collect function. That's something like a flat map. No, that's not like a flat map. I'm looking at is a sec.concat. That's maybe the one. I want to flatten lists of lists into a single list. Yeah, that's what I'm looking for. So forget I said anything about collect. I mean concat. So that's the principle I'm going to be trying out right about now. So principle is using the scan for every instruction. So let's grab our instructions first. I have 2 examples in here. This is the larger one with the 20 plus. Yeah, this is the larger one. Cool. So let's parse this one. These are all the instructions parsed, and now let's scan over them. And I'm going to drop into the sequence world, the sequence module, not the list module, because I have a small inkling of a spider sense that part 2 might have us repeat this thing a whole lot. I have not looked up any spoilers, but my spider sense is tingling. So this is the cycles for instruction. Let's call our folding function something like this. And we start with the default value of 1. So our state is just the value of the X register that gets threaded to our fold or through our scan, and this is the folding function that takes the value for X and an instruction. And it should return a value for X. So if we run this and take whatever, what was it, 5? We should get some values in here. And instead of an X, let's have it return a list of X, and let's start with a list of 1. That's a bit weird, right? Yeah, let's not do that. Interesting. The types have to line up. Of course the types have to line up. Maybe an unfold isn't that bad of an idea. That's something I hadn't thought about. If you fold or if you scan. No? What am I seeing here? We have a source of instruction. So T is instruction. And we generate a sequence of T. Yeah, okay, yeah, no, never mind. The principle still holds. The principle still holds. Let's see. Maybe scan is not a natural fit, or not an as natural fit as I was thinking. We could get away with it, I think. We could get away with it. But I don't like this, having the current value of x represented as a list. That makes no sense. So yeah, let's use an unfold. And this was what I was doing, but now with I was doing the concat thing in a different way in my previous attempt. So let's see if I get further with this list of lists approach. So if we unfold, then we need to do some more magic. Unfold takes a function that's called a generator, and it takes an initial state, and it generates a sequence of t's. What is what? Our initial value of state is the 1, so state is an integer. So that is indeed our x, and we should be... No, we cannot unfold. We need our sequence of instructions. We need to fold. I'm flip-flopping here. Am I happy with that? Okay, and if we call this previous, and it's a list of values, not too happy with that, but it might work. So yeah, this might work, but the only problem is that prev is a list of values from the previous instruction, so it can be 1 or 2 values. I'm not too happy with it, but for the sake of I'm here to grab my star fruits and not write the cleanest of Haskell reaching or Haskell adjacent code, let's go with this. So x is... So this will be a bit of a pain because it can be 2 and we always have to jump over the first one, but okay, we can do it. And then match instruction with a no-op. That's easy, we just return x again. And if it's an add x of a v, we return x because it takes 2 cycles, and then we return x plus v. So this was my brilliant idea. Let's see if this brilliant idea now makes sense. 8 minutes in, I thought I would have knocked this out in 2 minutes, so yeah, there you go. So these should be all the cycle values. And let's list it to see what we have in here. 1, 1, 16, 16, 5, and let's take 20 as the example suggests. 21, 21. That could be correct. We're not very sure. Sorry, it's the bigger example here. So yeah, 21 might be okay. I'm willing to see how far this goes. So that's correct. I'm just going to count out all the cycles. So how many do we need? Oh, you know what? That's actually it. So this is our cycle lists, and let's cache that. It's a sort of memoization. So if you loop over this thing 5 times in a row, it only calculates every element once. Let's grab, what do we need? 20, 60, 100, 20, 60, 100, 140, 180, and 220. So those are all the indices we need, or all the cycles we need to find this, the signal strength, or the value for x. So if we map over these, and we grab cycles item at this index, those are all the cycles we need. 21, 19, 18, 21, 16, 19. That is correct. And what do we need to do? We don't need to register x value, we need to signal strength, and that is multiplying the cycle by the value. Cool, we can do that. So let's first map them into tuples so we can keep track of what we're doing, and then let's do the multiplication. So that's list.map and let's multiply the values in the tuple. There we go. 420, 1140, 1800, 2940, 2880, 4180. Oh no. Everything went well, except x has the value of 18. Ah, and I see a 19. Dang it. We have a problem somewhere. So we have 21, 19. Let's put those side by side. 21, 19, or let's look at the bigger numbers. That was easier. 420, 1140, 1800, 2940, 2880, and then boom. And x should have the value 18. What's going wrong around 220? Let's see what's happening around 220. So this is what we're asked, but let's put 210 to 230 in here. Let's see what we get. .220 is 19. That's not correct. 219 is 18. Why are we off by 1? What's happening around that time? No overflows? No. Where are we in the program? We have just added 2 and will be adding 1. So there's an ADX 1 and an ADX 2. Yeah, we have that a couple of times. Is there a bigger number we can see? 1, 2, 1. 1, 2, 1. Where is 1, 2, 1? I'm not seeing 1, 2, 1. Is it plus 1? Plus 1, plus 2, plus 1, yeah. And maybe some knobs. Ah, there we go. Plus 1, plus 2. And right before the plus 1 we have the minus 6. Is that correct? 21 minus 6 is 15, yeah. Okay, so we're over here. There's a no op in there. I'm not seeing anything super strange. Why are we off by one for like one magical cycle? Let's take a look at everything around 20. Are those more stable? What should 20 be? 21. Oh, I don't feel like troubleshooting this. I had the nicest of times walking my dog. I even had some first snow of the year during the walk. And now I'm back figuring out off by one errors. No. Is it because we're taking the last instead of the first here? No, we need to take the last, right? I'm willing to just try it out. Oh, is it because I'm doing cached? Let's forget about that cached thing for a second. Yeah, let's get rid of that cache thing. Still nothing. It pains me to see that we are correct for everything except one magical problem. Why is it the last one in a sequence of 1, 2, 3, 4, 5, 6? Oh, during. I think in my thing. Let's try something here. My cycle, if I have a value at a cycle, it's not during, it's after. I think this is lining up, right? Yeah, this is lining up. I can't. Okay, but no problem. We're getting somewhere here. So what was my problem? Off by one, of course. Cool. I have no mutable state, but I have off by ones. The immutable gods don't fix those kinds of problems. Okay, but I'm a happy camper. I thought I was going to go to through Excel hell again, but apparently that looks like it works. So now let's run it on my input instead of the example. So these are all things I need. This is something I can put here. Let's parse my input and let's see what we get. It is a number I am willing to accept. And so is the website, so I'm a happy camper. Whew. This was a roller coaster. I thought, oh no, my second attempt, I'm gonna fail again. But thank God we got through it. Always check your off by ones. There we go. I'm copy pasting my file for part 2. And let's take a read here. Okay, that's that's a big part 2. So it seems like the X register controls the horizontal position of a sprite. Interesting. Sprite is 3 pixels wide, and the X register sets the horizontal position of the middle of that sprite. In this system, there is no such thing as vertical position. If the sprite's horizontal position put its pixel where the CRT is currently drawing, then those pixels will be drawn. Oh, okay. That's why we need signals. Okay. You count the pixels on the CRT. We have 40 wide and 6 high. Okay. This CRT screen draws the top row of pixels left to right, then the row below that, and so on. So yeah, okay, makes sense. The leftmost pixel in each row is in position 0 and 39. Okay. Like the CPU, the CRT is tied closely to the clock. The CRT draws a single pixel during each cycle. Okay, so it takes 40 times 6, 240 cycles to refresh the screen. Representing each pixel of the screen as a... what's this called? Hashtag? I don't know what the alternative word is. Here are the cycles during which the first and last pixel in each row are drawn. So cycle 1 makes sense, cycle 40, cycle 240 to refresh the entire screen. Yes, or to draw the entire screen. By carefully timing the CPU instructions and the CRT drawing operations, you should be able to determine whether the sprite is visible the instant each pixel is drawn. And the sprite is 3 pixels wide. Interesting. And what can we do with the sprite? The horizontal position. Okay. Okay. I need to see the example. So if the sprite is positioned such that one of its 3 pixels is the pixel currently being drawn, the screen produces lit, otherwise the screen leaves the pixel dark. That is very cool. The first few pixels from the larger example above are drawn as follows. So sprite starts at 1. And we have our cycles. And during cycle 1, we draw pixel 0. Oh, this is screaming for f by 1 errors again. So our sprite has 40. It's just going over the 40, I think so. And X is the middle position, right? X register is the middle position, the horizontal middle of the sprite. Yeah, okay. So it's executing at 50 and it's drawing position 0. Sprite is overlapping with 0, so boop, we draw. Makes sense. We're drawing position 1. And it's finishing executing at x15, but the register is now 16. So our sprite jumps, but because the sprite was there, oh my god, this is a timing nightmare. But the sprite was there during the draw cycle. This during and end, it tripped me up in my first attempt, and it's going to trip me up again. I just feel it. But okay, I see what's happening here. And this runs for however long. And oh, that's cool. 8 capital letters should be appearing. So we need what, 240? We need 240 cycles. That's why we ended up with 240 during part 1. Makes sense. So how do we do this? We just need to convert every cycle to a hashtag or a dot. And for that we need to keep track of the register, but the register is just the X value minus and plus 1. Sounds pretty simple. Yeah, sounds pretty simple. So instead of grabbing all these, we just need to grab them for what? For 1 or for 0 to 240? I'm tripping myself up. Cycle 1 and cycle 240. So I'm going to go from 1 to 240 inclusive. And I'm going to generate all the cycles or all the X values. That's probably this question mark. So for cycle 1 we have this, for cycle 2 we have this. Signal strength. Do we need signal strength? We don't need signal strength, right? So let's get rid of the signal strength. But there's the -1 thing, so let's not forget about oh, this is a signal strength thing, I'm sorry. So this can go, this can go. I'm not sure about the -1. So we'll have to try it out with the example and see what it gives us. Is the cycle number the pixel we're drawing? No, position 0. So that's the same problem I had as this. No problem, no problem. So this is the cycle value we had at that time. Yeah, it's okay. Oh, and the line goes from what? From 0 to 40. So we need to divide by what? Modulo 40? It's a it's a single line, but we go over it in 6 times. So yeah, there's a modulo 40 in there if we want to do it like this. And then that's the sprite location and minus plus 1. Something like that. Something like that. So that's x modulo 40. No, x is always... Why am I moduloing? X is always like something small, right? Yeah, that's always something like 1923. Forget everything I said about modulo. Not needed. What do we need? We need to know whether the cycle modulo 40. What's 40 modulo 40? Is that 0? Is that okay? 41? So 41. That should be 0 again. Yeah. Yeah, okay. What is this thing called? Position. Yeah, let's call it position. And if position equals x, no, let's then we have a bang if it's one apart or overlapping because our pixel is 3 wide. Otherwise we have a dot, right? Or a hashtag. Something potentially like this. Apps works with 2 arguments. So it's something like this rather, no? Oh yeah, you need to deduct. Okay, yeah. There we go. This gives us something, but figuring out problems will be interesting. Okay, but no problem. Chunk by size 40. Let's work on our example. So we're looking at the same thing here. And then let's put everything together in a string. No? What do we have with these chunks? Or we can do the string thing before we chunk, right? So for every character, this is a very long list, right? It's a very long list, so then we can map to string. Yeah, and then we can chunk into rows of 40. Yeah, and then for every row, we can concat. That was more what I was trying to achieve here. And that should give us something nicer. And let's paste everything together. That's not what I was wanting. Forget the pasting, this was readable enough. Ta 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 ta. Does this look like something? No, this looks off. 1, 2, 3, 4. This looks correct-ish, but then we're starting to completely miss the mark. So, yeah, this was a huge step, a wrong step. We're gonna need to go over the example in a slower pace. Is the first row correct? That would be nice to know, right? 2, 2, 2. Let's pull them up in a text file. That's something for work. There we go. We already have a problem, right? Oh dear. This. Yeah, we already have a problem in the first. What is it? 1, 2, 3, 4, 5, 6, 7, 8, 9. The 10th thing is already not okay. That's good to know. The 10th thing is not okay. So let's do the first 10. And we're expecting 2, 2, 2, 2, 1, 1. 2, 2, 2, 2, 2. So we should have 2 hashtags following each other. I'm randomly changing in off by 1 thing. That's not a good idea. 2, 2, 2, 2. Oh dear lord, but it solved the problem. Oh no. What was the maximum index again? 240. There's something weird about programming while tired. You have like all these instincts and gut feelings, but my system 2, my mode for intelligent thought, has deactivated. So I'm just doing shit. It got worse, right? Or it did not get worse. What I mean to say is maybe now we have our first row, but there's something completely off with our second row, right? It's like a nice alternation, 2, 2, 2, 2, 2. That's a nice alternation, but then we should have 3, 3, 3 alternation. Oh, it's a repeating pattern. I just noticed this. Okay, that makes it easier. So yeah, we are doing something wrong in the subsequent lines, so probably it's our modulo. Just gonna try something. System 1 has taken over. Why is there this why is there this lonesome dot in there? Oh yeah, it's because I did this. So let's get rid of the lonesome dot to keep it squeaky clean. There we go. Let's see what we get. I see letters. Can we ask ChatGPT? Can we ask ChatGPT what the letters are? It's been all the rage. I am somewhat impressed, but it's still a predictive language model, so to be expected. But yeah, it's pretty impressive. Let's see if it can guess. Can you identify the capital case letters in this ASCII art? Ooh, that was a hard, yeah. what letters do you see here? Okay, I give up. I see F, G, C, U, Z, R, E, C. F, G, C, U, Z, R, E, C. Last year there was also this visual output recognition thing, and one of my colleagues used a neural net, PyTorch. I don't remember what, but they used a neural net to detect the visual output, which I thought was very neat. Kudos. I'm not gonna amuse myself with that today. So yeah, there we go. Rough. I thought I had it all planned out before I started this stream. I thought this would have been 2 minutes of work, but sadly I've been working at it for 35 minutes. Still a very fun puzzle. This visual output thing, love it. The twist with the different cycle durations or the instruction durations, love it. That threw me for a loop for I think an hour. I had to resort to Excel. That's something I don't do every day, especially not for Advent of Code. So yeah, very cool puzzle. Let's quickly recap what we did today, or what my second attempt resulted in. My master plan was to use a scan, and we ended up using it. But I'm actually not very happy with the end result because of this thing, or at least especially this thing. I was thinking we can thread the X as the state, but scan. Yeah, the types did not line up, so a bit of a shame that I'm grabbing for an element in an array here instead of the X value, but that's a compromise. I am very happy to live with, and then everything fell into place, thankfully, and then I just flailed around with tweaking off by 1 errors until I got something that represented what we were hoping for. Not my proudest moment. I could have thought my way out of this as well. That would have been maybe better, but Tire Brain says no. We got there in the end. We got our stars. We got our star fruit. I am happy, and I wish you a nice day or a nice rest of the evening, and I'll see you very soon for Advent of Code Day 11. Bye bye.